My name is Vint Cerf. I'm one of the two original designers of the internet. Bob Kahn is the other one. And he and I have both stayed in this business in one way or another, trying to help it along for roughly 40 years. The internet enterprise involved persuading a lot of people that they should want to invest their time, energy, and money in making this happen. So as an engineer, I discovered that you have to be a salesman to do anything big. The original project was called ARPANET, and it was designed to share information among a dozen universities that were working on behalf of the Defense Department in computer science and artificial intelligence. And the government couldn't afford to buy them, each of the departments, a new computer every year. So they said, you're going to have to share. We're going to build a network. It's an experimental network. We're not absolutely sure it's going to work, but if it does work, then you can share each other's resources, and you can get access to each other's work, their software, which means that in theory you should be able to build on each other's work more quickly. And oh, by the way, we will fund everybody, so you don't have to feel like you're hiding information from your competitors. So that the decisions that were made induced acceptance of this framework. The next thing that happens after that original network is successfully built and demonstrated to the public is the recognition that computers could be useful in command and control. But if you were serious about that, then these computers would have to end up in mobile vehicles, in airplanes and ships at sea, as well as fixed installations. And although the ARPANET had been built with dedicated telephone circuits, tying the ships together with telephone wire, it doesn't work, and airplanes don't fly with telephone wires attaching them to the ground. So we have to use radio and satellite. That led to multiple packet switch nets using different technologies, which led to the internet problems. How do I hook all this stuff together? So that got solved by actually 1974. We thought this is a non-proprietary way of hooking computers and networks together. And historically, what you'd had in the past was proprietary networks. HP had its network, Digital Equipment Corporation, IBM. They had networks that only connected their own brands of computers. And we wanted something that was non-proprietary, so any brand of computer could be interconnected and any type of packet network could be connected to any other one. So the Defense Department could have its choice of any computer or network it wanted to, and oh, more important, it should be globally available. We turned it on officially in 1983, and it goes commercial in 1988 or 89. The reason that's important is that suddenly there was a market for products that would use these protocols. So Cisco Systems, Proteon, eventually Juniper Networks and others started making products that could be purchased by the consumers of this architecture, the educational community and the military. But since it was commercially available, now we had enterprises, the private sector enterprises, also making use of this thing. And we had academic communities in the rest of the world also adopting this stuff, and they became customers for this equipment made by Cisco and others, or they built their own. So this thing rapidly evolved into a commercial enterprise. And then Tim Berners-Lee shows up in 1991 and releases the World Wide Web on everyone, and nobody notices. What happens after that is that Mark Andreessen and Eric Bina at the National Center for Supercomputer Applications figure out how to build the Mosaic Browser, which was a graphical browser. This made the internet come to life. So before we had remote access to computing, we had email, which was developed in 1971. We had file transfers, we developed contemporary with that. But once we had the World Wide Web in a graphical form, suddenly the internet is like a magazine. I mean, you've got images, you've got video, you've got audio, and people recognized that this was something different. We got all excited about sharing information with each other. So this avalanche of information flows into the net, and pretty soon nobody can find anything because it's so big. So what happens after that? Search engines, right? Alta Vista, and then Yahoo, and then Google, and Bing, and A9, and others. So the point I want to make with this long preamble is that a lot of people had to decide that this was important to them to invest in. Well, there was a company because it had a business model, or a research institution that wanted to get access to research information and to collaborate with others, or the Defense Department that wanted to use this for command and control, or enterprise that discovered this was a way of marketing their products and services. Everything lined up really well to make this attractive to a lot of different people who had to decide they wanted to be part of it. Risk-taking was an important part of this, and the capacity to accept the possibility of failure was an important part of it. What was important about the government involvement is, first of all, a persistent level of funding over years, something industry would never do. The ARPANET project went from 1969, or 68 actually, to 1990. That's 22 years. The Internet project starts in 1973, and actually, it's never not had funding since that time of one kind or another from either the Defense Department or the National Science Foundation or other research institutions. This ability to persistently fund high-risk research and to target that support to the best people you can find, to allow others to participate and to take advantage of and use the technology, to commercialize it if they want to. All of that is enabling. And so the government deserves this enormous credit, not just the US government, but other governments who similarly invested in the research community. The permission for the commercial sector to engage and connect to the government-sponsored backbones, which came in 1988, was a very important part of the commercialization of internet, because it allowed the private sector to discover that there was a business to be had offering internet services to enterprises without having to actually build a backbone network that spanned the United States. It's really important to recognize when to get out of the way. This architecture was designed to be extraordinarily flexible. You could sweep in new telecommunications technologies into the internet architecture whenever they showed up. And we knew that that was going to be a problem. When the design was done in '73, we said, in the future decades, there will be new communication technology invented. We don't know what it is, but we don't want to be sensitive to it. We don't want our design to break because somebody introduced a new communication technology. So we had these little internet packets, they're like little postcards, and they don't know how they're being carried. It's very careful to make sure they didn't have any idea how many different networks they went through and whether they were optical fibers or satellite links or radio links or dedicated connections. So that meant that every time a new technology came along for communication, we could just plop the internet down on top of it. The second thing, which he also very consciously did, is that the packets don't know what they're carrying. It's like a postcard that doesn't know what's written on it. So the reason that's important is that when you invent a new application, the network doesn't have to change because it didn't know what was in the packets to begin with, and it doesn't care. So that means that anyone who wants to build a new application is free to do so. We call this permissionless innovation. You don't have to go and get permission from anybody to try something out. So this has led to literally an uncounted number or maybe even uncountable number of new applications on the network. If you needed a new protocol, as long as it would sit on top of the little internet layer, it's fine, go ahead. You can standardize it, you can make it private if you want to. So this is a virtue, and it continues to be exploited today. 3D printers have created an interesting potential business where you do designs and sell the designs and send the designs through the net, and other people print things out for their own purposes. This same engine could turn into something even more innovative if you were willing to show your design and let somebody else change it, so they begin to literally reinforce each other's creative ideas. Then you get even stronger side effect. And this happened with the World Wide Web, because everybody could see, if they wanted to, the actual source code of every single web page they were looking at. And if they thought something was really cool, they could look at that, copy it, and modify it. And when they did that, other people could see what they had done and build on that. So there's one of these virtuous circle constructive environment. And I think if we can figure out how to harness that effect using the kinds of computing and networking technology we have available today, that we could have quite an impact on the range of jobs that people could usefully explore.